All right, here's that promised help, though a bit later than I promised, of how to tackle that homework that's due on Monday. If you take a peek at each of these, it says graph each equation in the appropriate window. And I'll tell you about my window here in a minute. I'm just going to kind of walk through a couple, then I'll go back and fill in the window parameters and tell you how that goes. But first thing you want to do is graph it, and then it says draw the tangent line at the indicated point. So this first one is at x equals -1, so I put a little marking on the graph of -2x. How you decide to graph that is your choice. The -2x is a line with a slope of -2 and a y-intercept of 0. So I'm just putting it going through the origin 0 and going down 2 over 1, down 2 over 1. Or if you used a device to graph it, that's fine. But it's a graph you should definitely recognize. The deal is it has a slope of -2, and it always has a slope of -2. So if I do a tangent line at x equals -1, like I've indicated there, it has the same slope as the line does throughout. So it should have a slope of -2. On the next one, here's the graph, 1 minus x squared. I know it's an upside-down parabola because of the negative in front of x squared. The 1 is like a vertical shift, it's up 1, or just graphed it on a calculator and saw these things. It does go through -1 and 1. That's good things to know. It says get the slope at x equals 0. So if I do that, or the tangent line, you graph it there, so it touches, and you can see it's flat. Well, flat is a slope of 0. Slope is an indicator of steepness, and it has none. It's flat, so that's a slope of 0. Okay, going to the next one. So I'm going to label those in here. M equals -2, M equals 0, kind of eyeball type things. You can totally do those. Window, by the way, for each of these, I did the x's and the y's. The way I have this written is your x scale is from the left -5 to 5, and vertically my window goes from -3 to 3. It seemed to be a good window to fit all this stuff in. And so if that's on your calculator or otherwise, I just wanted you to get a sense of how big I'm making this, how it's zoomed out. So that's my choice of window. Okay, down below, let's graph this next one. Nice cubic function at x equals 1. I'm supposed to draw a tangent line, and it's flat again. Now, it may not look like it's flat to you. You're wondering, can that really be a tangent line? Remember, tangent lines can pass through the function. It's just the resting, it's the steepness at that spot. And it kind of progressively, if you draw in all the tangent lines in and around it, you can kind of see as you go left to right, those little tangents kind of make their way toward flat in the middle there. They're kind of up, lower, lower, flat, and then it goes back up again. So somewhere in the middle, those go flat. At x equals 1, those tangent lines go flat. Okay, so there's my nice tangent line. Slope is definitely 0, so I darken it in for you. Finally, then there's this x squared minus x to the 4th. Definitely use a graphing utility. I'm using that same window, by the way. -5 to 5 for my x's and -3 to 3 for my y's in that window. If I go to x equals 1, it's right on top of, it's right on that intercept. It's where it crosses. Definitely downhill. Looks really steep. Steeper than like -1. So I'm thinking negative something bigger than 1. And it's kind of a guess at this point. It's hard to tell just looking at it. Well, that's where we should use our derivative calculus stuff. If I take the derivative of each of these, that gives me a formula that tells me the slope of the tangent at each of those points. So I want you to use that. Employ the derivative for finding these slope values that I've already found for the first 3. Number 4, I really need the derivative because I can't sit there and guess what it's going to be. I need something to help. Okay, so there's my window. So I don't know the last one there. So let's go back. In the first equation, the derivative of -2x is just -2. And something you should know is that the derivative of a number times x is always just that number. So that's a rule to keep track of. We can explain it more later. The second one, the derivative of 1 minus x squared, derivative of 1 is a constant at 0. The derivative of -x squared, if you multiply the 2 times -1 out front and reduce the power by 1, you get -2x. So it's like 0 plus -2x, or y prime equals -2x. That's our derivative equation. So to get the slope, these are our derivative equations. That means if I plug the x into those derivatives for each of these functions in number 1 and 2, I can get the slope that I already know, at least confirm it with this derivative stuff. So here goes. One of the things you want to notice on the first question, number 1, is that if I try and plug in x equals -1 into my derivative, there's like no place to put the x. Well, that actually is a big indicator. The slope on that line is always -2 regardless of x. So there's no place to put an x because the slope is always -2. So when you have a derivative equal to a number, that means the slope is always -2. It means you're dealing with a line. In the second one, if I plug 0, the point of tangency they're asking for at x equals 0, if I put that into my derivative -2x, so it's -2 times 0, I get out 0, which we already got. We knew that. So that's the derivative working to answer the question that we already knew the answer to, but you're seeing it in action. Okay, that's kind of cool. Down below, let's use it for this number 3, because that's it's got a nice little derivative going for it. The derivative of that one is 3x squared minus 6x plus 3. I'm going to go ahead and assume you kind of know that power rule, where you bring the power out front and reduce it by 1. So I'm going to live with that for a minute. If you put x equals 1 into that derivative, I'm expecting an output of 0 because I know the slope at x equals 1 is 0. So I'm going to plug it in there. Here it is. If I do a little arithmetic, sure enough, 3 times 1 minus 6 is -3, plus 3 again is 0. And it gives me exactly what I expected. Now that I know the derivative works, let's just use it on the last one. Let's just employ it. Derivative of x squared is 2x to the first. Forget the first. Derivative of x to the fourth is 4x cubed. So I got that. Put in 1. Excuse me. Figure out what I get. 2 times 1 is 2. 4 times 1 cubed is still 4 times 1. 2 take away 4 is -2. That's my slope at that tangent line, -2. And the derivative made that a lot easier. I want you to do that for the remainder of the assignment, so hopefully this gets you off on the right foot. Email me with other questions.